Hello, everybody. Good morning. Welcome to our workshop of today. We'll start with a few minutes before 10 because we have one of our speakers who will have to leave a bit earlier. So welcome to this workshop on how can augmented reality enhance first responder capabilities. This workshop is organized by the project Respond A, and we have the pleasure to have also with us two other projects that are also covering the new capabilities that is offering augmented reality. That is a faster and ingenious project. I will give the floor first to Sean from VContact, which is a partner in Respond A project. So, Sean, if you can just give a few words of introduction of welcoming, and then I will come back to give you some rules for these workshops.
Sean, I sent you the request. Okay.
Yeah, I've got it. Sorry about that. It's just I muted earlier and then muted again to keep the noise down. Marie-Christine, thank you for changing the order at the last minute. My apologies. I've been called to a meeting with DG Home and they've changed their agenda. So when the bosses call, you have to go. First of all, I'd just like to welcome everybody to today's workshop. I see there was nearly 200 registrations, which is quite impressive. It would be much better to be able to have this kind of meeting in person. We have many partners in many places, very nice places in the world. Could have had a very productive meeting. I will be joining the meeting later on again today, and it'll be interesting to see and hear the different input and feedback and the opinions of the researchers, companies, and other practitioners, especially the practitioners in the project and their impressions so far. When Responder was set up many years ago at this point, it was in a very competitive call. It was successful. There's many proposals which were not. The continuation of the DRS topic last year was even more competitive. There was projects that scored 15 out of 15 which weren't initially funded. So it just goes to show the interest, the demand, the possibilities that are coming up with the new evolutions or new technologies that are coming through and coming on stream. Particularly when we look at the reduction in the cost of processing power, low power processors, wearable computing, and above all, from my own perspective, the introduction of 5G in the equation, where there's so much of the offload can be done from the equipment that's carried to back-end infrastructure. With that, I'd like to hand it back over to Marie-Christine and let her close off. Thank you.
Yes, thank you, Sean, for this word of introduction. So I think that we're going to share again the program of today. Please, Jean, can you please share? Yes. So here is the program and the list of speakers that you will have the pleasure to hear today. So we'll start with George Bustras, with our project coordinator. We'll give a general introduction of the project, and we'll have VContact partner who will present the possibilities that our AR is offering for enhancing first responder capabilities, and how it will work within Respond A. And we'll have the view of the practitioner, which is also very important. It's not only adding technicalities, but we have to see how it will be used and how it will help practitioners. And then we will have also some presentation of ingenious project and faster projects, which are dealing also on the same core topic than Respond A, so new technology for first responder, and they will present what they have been developing within their project. I have to say, and that was also mentioned by Sean, that we have more than 200 participants for this workshop, coming from different groups, and that's also very important. both coming from practitioners, research on industries, coming from EU countries, but not only, so coming from also neighboring countries like Bosnia-Herzegovina or Kosovo, but also from more distant countries like Australia or Algeria or Pakistan. So we'd like really to warmly welcome all of you. There will be some very simple rules for this workshop. Non-speakers are muted. We also kindly ask non-speaker to turn off their camera. You will have the possibility to ask questions, of course, using the chat, and we'll pick up each time some questions after the presentation, but maybe not all of them. So presenter will also answer and interact with you under the chat directly. And of course, everything will be made available after the workshop. You will receive the presentation on the recording. So let's have an interesting workshop now, discussing about artificial augmented reality, And let's start with our first speaker. So George, the floor is yours.
Hello, good morning. How are you? Everyone, let me just share my presentation. Sorry, excuse me for a minute because classic, like when you want things to happen, they don't. Spare with me. Let me mute myself for a minute to share enough to myself and find the presentation. Okay, it's coming up, hopefully. There you go. Okay, so let me... Okay, so 1, 2, 3, go. All right, thank you very much for bearing with me. I'm known to be, like the typical recipient of Murphy's Law, like when you want things not to happen, they happen, or the opposite. Well, I don't know. And thank you very much for that. I was amazed, that's why I was in awe, because I saw almost 100 people attending, which is great. And I want to thank very much the organizers, and I have to comment on PSCE, my colleagues. I do that quite often, but I believe that it is very important to reward people. And the most professional organization in organizing dissemination activities for Horizon 2020 projects. I was about to say FP7, this shows my age, but we are in Horizon 2020 and soon we're going to be in Horizon Europe. I hope we haven't entered it yet and I'm making a mistake. So yeah, Respond Day. Respond Day, what is Respond Day? Respond Day is a project that has been funded by the European Commission under the Technologies for First Responders call. I'm not going to say a lot about the participants because I have a special slide later on. It is a 36-month project. It started in June 2020. So we are approaching slowly the first year. I had a discussion with Tassos Dimou, who's also working, he's going to present his project later on. And we had a discussion and I was amazed because he told me that their project started before COVID. We're a pure COVID-19 baby. Everything has happened under COVID. And I have to say that I'm extremely pleased because my colleagues, and I forgot to mention my esteemed colleagues, Dr. Cleo Varianou Michelidou and Dr. Christos Argyropoulos, without the help of which we wouldn't have been here today. Both my colleagues at CERIDES at European University Cyprus, as well as my colleagues in the consortium, very professional, very resilient. We never had so far any sort of complaint about the difficulties that exist because of COVID-19. I'm grateful about that. Things are going correctly. We have something coming up this summer that it is going to be challenging because we have a large-scale exercise, not a large-scale exercise, but a pilot study. But let me start talking about the project. So the aim of the project, I will try to make it, like more in layman's terms, so that people like myself can understand. And what is it? It is about developing new technologies about first responders. Why? Because the work of a first responder, especially given the new developments, climate change, as well as the intensity of natural and non-natural catastrophes that occur in the last few years, and unfortunately, they're going to continue occurring even stronger in the next years. They make the job of the first responders even more demanding. Having said that, imagine everything that I say with the added risk. Don't forget I'm a risk assessor, so things in my mind work in a risk perspective. We don't only have now one risk, a natural catastrophe or a like a man-made catastrophe, but we have concurrent crises or risks rather happening. We have COVID-19, so things are becoming more complicated. So we're talking now about complex crises, and unfortunately, at some point, we may see also hybrid risks or even systemic risks. Many countries have been stretched. I believe that we're going to have some, I don't want, but okay. Sorry. Okay, so let me just. Someone press something. Okay, let me go back and say that why are we interested in this? We're very much interested in promoting this new technology. Can you please mute yourself if you don't mind? Yes, thank you. So basically, we have the new technologies that are going to be used for early assessment, safety assessment, safety of practitioners and first responders. It is a very under-researched area. We take things for granted, so this is something that we very much look forward to achieving. And also, of course, from a technological perspective, to create a clear common operational picture. So what are we doing? We are empowering in the battle of operations the practitioner, the first responder, but at the same time, we are creating a technological framework that all the necessary information needed for the well-being of the practitioner, of the first responder, as well as to have an operational picture, are transmitted in a centralized location, and decisions can be made from there. And that's how it looks. You can see a picture. What are we doing here? We're going to be using 5G. So this is the definition of a brand new technology, next generation. I'm not going to make the typical joke about vaccination and 5G. You can imagine this. This is an internal joke in the consortium. And basically, what are we going to develop? Health sensors, environmental sensors, as well as emergency activated sensors that in case of an issue, they will provide feedback in case of a fatal accident or an injury. So how is this going to look like? This is going to be in the form of a wearable chest band or clothing. The exact technology we are about to define with the help of our good friends in the consortium, Hellenic Instruments, that they are about to decide on how we're going to integrate this solution. If you are a computer scientist, I think this will be the slide that you will say, at least, like there is something that I understand. I'm not a computer scientist, so I'm not gonna talk very much about this. There is a methodology that it is that will be used. It is a methodology that foresees 5 different layers. But I better have my technical manager explaining that much more than that. We had a couple of weeks ago, we had a very interesting presentation at the European Commission internally to have a go at explaining our solutions from a policy context. This made me think on what are we doing in order to not talk in technical terms, and what like a couple of examples that I wanted to use was, first of all, to talk about training as a tool to engage end users. End users are the, how can I say that, they are the mecca of security projects in Horizon 2020. The reality is that we need to find creative ways of engaging them, and I think we have managed to achieve this so far on the 10th and the 11th of September 2020. Under a virtual environment, despite COVID-19 difficulties, we managed to, with the help of our colleagues from Pau Costa in Barcelona, we managed to have an online training session. And the first training session was focused on addressing maritime accidents in coastal and port areas. Why? Because we have also the port of Valencia in our consortium, and this is an interesting point, an interesting theater of operation for our project. How are we going to test and promote exploitation of our products? We have arranged for 3 case studies. These 3 case studies, they have distinct differences between them. The first one that is going to take place, hopefully, nowadays, you cannot make plans for more than 5-10 days ahead. Hopefully with vaccination, things are going to be happening in a more stable manner in the future. So what we have is the first case, it is going to have an emphasis on fire. And basically what we're going to do is we're going to test the technologies that are relevant to this scenario. Of course, we plan to reduce the time needed for mobilizing the necessary first responders. Of course, it is about improving and establishing new standard operating procedures for complex emergencies. So watch this space, because towards the end of the summer, this case study is going to take place here in Cyprus. Our second pilot, it is going to have an emphasis, a focus on an earthquake. It is going to happen in Athens. We're going to be focusing mostly on the introduction and the integration of 5G technologies. So it is going to have a mostly telecommunications focus. We will try to validate the support from the broadband network of the simultaneous operation of many data-rich services, like, for example, virtual reality, augmented reality, and augmented reality is the keyword for today's workshop. As I said, 5G is going to be the most important part that we're going to be paying attention to in case number 2. In case number 3, it is going to be taking place in Valencia. and we're going to establish a safety assessment and an early warning framework that will protect first responders. So we're not only going to be exchanging information live, but we're going to be using advanced technologies in order to forecast and warn the first responders. So all in all, the technical solutions are in the table. There is quite a lot to be done. There is also, of course, an emphasis on exploitation. Let us not forget that all these technological solutions that are foreseen by Horizon 2020 projects, they should lead in a future stage, of course, but they should have a channel of direction towards the exploitation of these products in the future. Responde has been designed, it has been written up in a way to hopefully foresee the final outcomes ending up in TRLs between 3 and 6. And of course, as you can understand, this will be a pre-commercialization stage, so more investment will be needed. We are very happy and we are very open to introducing and integrating new technologies. I'm very happy to report here that we have already made some very good friends, some very good collaborations, ongoing collaborations that are not going to be collaborations only in paper, but they're going to have a practical approach as well. They're going to have a practical conclusion, and later on you will see our friends and colleagues from FASTER, and we already plan common activities, common use of technologies and various other aspects. We also are in collaboration with iProcureNet, which is another project. We are in the first year, and we hope that since we are enthusiasts of promoting the European idea, and the narrative behind all these projects is to promote the European idea, it is very important to create opportunities for real collaboration between EU-funded projects. I have to say that initiatives like the one that I spoke about before, that was organized by RIA, the Research Executive Agency of the European Union, they are there to be catalysts for the promotion of this collaboration between the various projects. We really want to see things happening in terms of collaboration. I think there is a lot of power that can be drawn from these collaborations. This project wouldn't have been happening, it wouldn't have been a success so far if we didn't have all this great team of collaborators. I'm not gonna individually mention all of them because thankfully there are 34 of them. We are 34 partners in this consortium. So if you want an extra presentation just to present the partners of the consortium, I can do that. We have, let me just say very quickly that we have a few, like sub-categories of partners. We have large industries, actually some really large industries. We have first responder organizations. We have SMEs. It is important to promote the work of SMEs in a European project context. And of course, we have research institutes and universities like the one that I'm working for. So there is a lot of information about all of this in the website of the project, and I believe that I'm on time, right? Thank you. Thank you very much. I will be here for possible questions that you may have, but I think it is time to say goodbye.
Thank you, George, for this presentation, overall presentation of Responde. Now we will move to more the topic of our workshop today. So I'm pleased to give the floor to Arbil for our different, she has 2 presentations, which is ambitious. So Arbil, the floor is yours.
Thank you, Marie-Christine. I will share the screen. Let me check. Okay. I guess you are already seeing the screen, right?
Yes.
Okay. Well, my name is Arbil Arregui. As Marie-Christine mentioned, I come from Bicontech. We are leading the work package in charge of augmented reality, mission critical communications, and common operational picture. So I will go to present 2 small presentations. The first one will be a quick introduction to augmented reality and some of the potential benefits that it has for first responders. And the second presentation will be more focused on the application in the project responder. So very briefly, in this first presentation, I will go to 3 main blocks. For those of you who are not very familiar with augmented reality, we'll see what it is. Well, the definition of augmented reality is that it is a kind of real-time, direct or indirect view of the physical real-world environment, which is somehow enhanced or augmented with additional information created by a computer. Okay. Its main objective is to make things easier so that we can bring virtual information on top of the real-world scenario. And it somehow enhances the user's perception, and it helps interaction with that real world surrounding him or her. Well, we can talk about augmented reality and also virtual reality. These are 2 different concepts that sometimes they may be confused. The main difference is that virtual reality immerses the user inside a synthetic environment. The user cannot see the real world around him or her, and this is not the case of augmented reality. Augmented reality, in case of, instead of replacing the surrounding, it somehow supplements it. And then virtual and real objects coexist in the same space. This is the main difference between augmented reality and virtual reality. Also, we can talk about mixed reality, and this is a concept that you may have heard somehow. And it is a kind of combination between augmented reality and virtual reality. We can say that it is a continuum from the real environment towards a completely virtual environment. If we go to YouTube, perhaps to the literature and surf the web to look for different applications of augmented reality, you are going to find many, many different applications. They go from industry to the health sector and entertainment, games. There are many, many applications in education. And it is a technology that it has been applied to multiple sectors. Well, we will go to some technological aspects now. We can classify AR technologies in 3 big groups. The first one is based in marker recognition. And using marker recognition, it can be a natural marker or an artificial marker. We need to have a well-known reference element in the scene, so that the AR solution is able to recognize that element and overlay additional information according to where that element is located in the space, or any information that that marker provides to the AR solution. The next category is location-based augmented reality. This is somehow different, but the main focus is to have a geolocated position of the user as a reference, and also the heading where this user is looking at. And the third category is one of the most complexes, we can say, is based on simultaneous localization and mapping, or it is usually known as SLAM. This kind of technology recognizes the different real-world planes, for example, the floor or the walls, for instance, as the user moves, and it uses these types of references as a reference to overlay information. We have added this table, which summarizes different types of frameworks that are currently available, because it gives a good overview somehow of the different technologies, what kind of functionalities they provide, and what kind of platforms they support. We must note that most of the time, the hardware device used for the augmented reality solutions and the framework, the software framework, are tightly coupled. So perhaps if we go to decide to use a kind of device, maybe we need to link to a specific technology. I won't go into details, but just for you to let you know that we have many different frameworks available. We already mentioned something about hardware. It is a big part of the augmented reality solution. The biggest categories that we find here are three. The first one are head-mounted displays. For example, we can talk about glasses or goggles, helmets, and we can discuss about two different subcategories here. The first one is based on optical see-through displays, and this provides an AR overlay through a transparent display. And the second one is video see-through displays. In this case, it captures video from a video camera usually worn in the helmet or in the glasses, and it is used as a background of the AR overlay. The second category are handheld displays, and these are easily smartphones or tablets, and many of the frameworks that we have explained in the previous slide can be used in these displays. The current capabilities of processing in these type of devices are able to give good quality solutions for AR visualization, especially if we want to overlay 3D objects in the virtual space, for example. And we can talk about a third category related to spatial or projection displays. These are somehow different, but the desired virtual information is projected directly on the physical objects. Okay, as some applications and limitations for responders of using this technology. Well, first, we would like to discuss somehow the different stages that an emergency management may find. And we have 4 stages. The first one is the pre-emergency stage, which is focused on the mitigation. It tries to reduce the risks and prevent the impact of any type of crisis. The second stage is the preparedness, the near emergency stage. And it is focused on taking measures to develop and improve the crisis management, and try to reduce the response time and improve the operation capabilities. The third stage is the response at the emergency crisis moment. and it includes the crisis time actions to be taken, normally focused on rescuing people or preventing the loss of property and casualties. And then we have a fourth stage, which is called recovery. And this is focused on measures to reinstate normal life and try to recover to a previous state. So AR applications could be applied in different stages, but we will go more in detail afterwards. For example, to explain in which stages we apply these different technologies in Responde, for example. If we go to the literature, some of the authors have published works explaining or proposing how AR capabilities can be applied to different types of challenges. One of the challenges is to minimize the required user input. This can be used by the use of gesture-based commands, for example, and this can be helpful for first responders. Also, the overlays of AR can be helpful in the visualization of spatial information. For instance, we are able to overlay information about distances or building heights, for example, and this reduces the overhead for the first responder. We can also filter information to try to reduce the information that is shown in the display or in the screen, so that it shows only the necessary information for the commander. Another example is the use of video or images. This can be used to share information among first responders. Also, the use of multi-perspective views, because augmented reality helps you changing the view from the real surrounding that you are seeing, or you can overlay any other kind of perspective view. And also, if we are able to predict trends or any kind of incident that may be happening in the short future, we are able to overlay that information also to the first responder, so that it can help to see what could be coming next. Okay. Well, this is one of the examples that we find in the literature. In this example, this application was focused for firefighters, and the augmented reality application here shows additional building information to the first responder. In this case, we can see that it is displaying information about how many families live in that building, how many people are injured, and that kind of information. So this is a kind of example that we can find, but the truth is that many different applications can be found in the web about application for first responders. But it is true that most of them are focused on the training and the preparedness of the crisis. Okay, and some limitations that we find regarding AR in these kind of sectors. Well, the thing is that the maturity level is somehow low in some specific cases to provide some services. A very important key topic here is that the environmental conditions for first responders are extreme many times. So this can be quite limiting for the use of some kinds of devices. Also, according to the application, if we aim to overlay 3D objects on the scene, or the use of SLAM, perhaps, battery life might be limited. So if we are trying to cover a very large emergency, this must be taken into account. Also, well, high quality renderings and compositions may not be feasible in real time according to the device that we need, because if we have limitations due to the extreme environmental conditions, we may be able to use one kind of device or not. And well, we find that the different heterogeneous needs for different types of emergency first responders require a high level of personalization. Okay, these are some references that we used to build this presentation, but I'm finishing now. So now we can go to the application of AR in the Respond-A platform. As I mentioned, we are leading the work package that is in charge of augmented reality. So I will try to explain at this stage of the project where we are, which were our main objectives in the project regarding augmented reality. We will see how this is included in the general architecture and which are the proposed solutions that among the partners have proposed. And we will discuss very briefly how these solutions can be applied to solve or to try to tackle some of the challenges that we will be finding in the different use cases or pilots. So, as I mentioned, the main objectives that we have in the project to discuss augmented reality is that this work is framed under the Work Package 5, which is called Common Operating Picture through Augmented Reality and Mission Critical Communications. So we have included in this presentation 8 main objectives that we will be considering. The first one is that we aim to enable operators to have an integrated common operating picture. The second one is that we aim to have personalized way of viewing user information and models, so that we can personalize all this information to each kind of end user. And these end users can be different depending on if they are located at the control center or if they are first responders in the field. The third one is that we aim to experiment and assess different ways of using augmented reality and how to integrate these ways in the responders' operations. The fourth one is to organize a coherent user interface on the different levels of operations: command and control room, firefighter, police officers, emergency medical technicians, and so on. Because in the project we are covering different types of first responders. The fifth objective is to minimize somehow the cognitive load required by the first responders to manage all the information that they receive from different sources. We will also try to integrate the presentation and interaction components, because we aim to provide a framework capable to be adapted to specific needs. The seventh objective that we have is to analyze different hardware solutions to host these augmented reality applications, especially to be able to be operated in real operational conditions. And the eighth one is to manipulate and interact multimodally. This can be by the use of gesture commands, voice commands, or different types of multimodal interaction options. Okay, so the general architecture and the AR solutions that we will be providing. This is the current figure that we have to somehow conceptualize the different elements that we have in the project. This is the general architecture overview. If we go more in detail, we can talk about having some elements in the field side of the first responders, and other blocks or other modules at the command and control center. We talk about a mobile command and control center because during the project we envision to have, for example, a mobile van that is set up in a concrete location where the emergency has happened. So we can talk about somehow a client side in the field tools and a server side in the mobile van tools. The augmented reality is represented in different modules here, but they are not isolated elements, because we have many different other supporting technologies that are somehow linked to the augmented reality solutions that will be provided, that we will be providing. For instance, in the field tools, we also have location tracking solutions, 360 video, triad systems, and on the server side or the command and control center, we also have some supporting solutions like the sensor platform, the triad platform, or the video and audio platform. But these are not the unique ones. These are the main ones. But we need to mention that many modules and many elements in the architecture are somehow supporting the augmented reality solutions. Okay, to try to understand the needs of the first responders in the project, a questionnaire was prepared for them. There were some questions regarding the use of augmented reality and virtual reality. We aim to know their capability or their willingness to be wearing different kind of devices, because it is well, the use of smartphones or the use of Google's or helmets might be different according to what kind of first responder. So in this questionnaire, most of the answers told us that first responders are able to carry and use a smartphone sometimes. Regarding helmets, most of them, they don't usually wear a helmet during their operations, but they could. And for example, 3 of them, they told us that they usually, well, they already wear a helmet. So perhaps we need to take into account that if they already wear a helmet, we are not able to provide them with an additional specific helmet that could not be used together with the one that they are already wearing. Some other questions were related to Google's. 5 of the 9 questionnaires told us that they were able to wear virtual reality goggles sometimes. This is important to know because, as we mentioned, virtual reality doesn't allow you to see the surrounding world. So this might be impeding sometimes in the real field operations. And also, 4 of the questionnaires, we got answers about not being able to use helmets with augmented reality data that without impeding their operations. Okay, so I showed this slide in the previous presentation, if you recall. In this case, inside the Respond A project, we are going to tackle somehow the preparedness stage and also the response stage. We are not going to tackle the pre-emergency or the post-emergency stages. And I will give you a brief introduction of the solutions that we proposed. So during training or this preparation stage, we will be using two types of devices. One is for virtual reality and other for more augmented reality related devices. And this is somehow focused on one of the work package, one of the specific work package we have in the project, which is linked to the training. We have a specific work package for that. So, and during emergency, the solutions that we have proposed are a thermal video. Using a thermal camera, we are able to overlay additional information to the real world that we are seeing. A solution called Mcx Augmented Expert. This is a solution based on mission critical communications, where different groups are able to share video and annotate specific elements or notes over the video and share among the different first responders in those priority groups. Another solution is the one we call the location-based services. These are focused on the geolocation of first responders, other first responders, risks, objectives that we can geolocate somehow. Also, we are going to provide a solution to handle casualty health records. This is envisioned for paramedics in the field. And also, we expect that having wearable sensors, we are able to provide alert status with the alert status to the first responder that are wearing these kind of sensors. According to the devices that we expect using in this case, we envision to be using smartphone and tablets for some applications and specific augmented reality glasses to overlay information for the first responder who is wearing those glasses. Also, during emergency, apart from the augmented reality solutions, we will be providing a 360 video, which can be a camera located over a drone or over a robot, and this can be applied by the use of virtual reality goggles, and the user is able to see the 360 video as if it was in the location where the camera is. Okay, then in the next presentation from Valencia Port, they will be giving some specific applications in different scenarios that they are working in the pilot. But to see some examples, for the location-based services, for example, we envision to have a map where the different locations of the first responders are, and the augmented reality application is able to display the location and distances to other first responders. So this can be helpful in situations where the field of view or the line of sight doesn't allow to see where other people are located. And also, this small proof of concept that we did, showing how if a user is walking and reaching an objective, the application displays how the distance to the objective is reducing, and it helps orienting to the first responder, perhaps in unknown environments, or for example, with low visibility conditions. Okay. So I will go very briefly to the use cases. George Bustras already presented some of the main concepts expected in the pilots, but I will go somehow to the concept of these use cases. The first one will tackle a severe forest fire, and it will include actions performed from the moment a fire breaks out up to the deployment of the first responders, and a scenario where firefighters go missing, citizens trying to escape from an area affected by the forest fire, and the forest fire that approaches a critical area. The second scene is focused on a severe earthquake, and it damages buildings and provokes fire. And this will have two sub-scenarios. One is to rescue a victim inside a collapsed building, and the second one is to rescue a victim and a rescuer inside a flaming building. And the third one is related to natural and provoked disasters in port areas. In that case, one scenario will focus on an oil spill accident, and the second one will focus on a crash of two trucks in an area near to the port, generating toxic gases. So to these use cases, we have tried to match somehow the solutions that we have proposed and how they can be potentially solving or helping somehow the situations that we can find. For example, in the use case scenario of having a fire, the main challenges that we find are the high temperatures, for example, low visibility, difficulty to reach objectives, the fast response needed, and very high health risk for responders. So we propose the use of a thermal camera, location-based services, casualty health record, and wearable sensors to alert about their status. In the case of smoke and toxic gases, also we may have low visibility, limited human access, and health risk for the first responders. And in this case, we envision to be using the 360 video for virtual reality, location-based services, and also casualty health record and wearable sensors alert status. In case of missing victims or first responders, we may have difficulty to trace an extensive outdoor area, and we will be using thermal cameras and location-based services potentially in this case. In the case of hazards in critical infrastructure, the risk or solutions may be unknown without a special expert input. And in this case, we think that perhaps the thermal camera and the Mcx Augmented Expert could be useful. In the case of collapsed buildings, we may have difficulty to locate people and possibly have a high number of victims. So we also propose how to apply our solutions in this case. And in the case of maritime spills, we may don't know the real extent of the spill. We may have difficulties to estimate the displacement of this spill or to locate bathers and areas in risk from the coastline. So we also propose different kinds of tools to be assessing these scenarios. You must note that the augmented reality solutions are not able to provide the full solution by themselves. As we previously mentioned in the architecture, we are using many different modules supporting that, supporting the AR technology to have information, for example, from drones, from other types of sensors, wearable sensors, as we mentioned, and these types of modules are providing the real information that the augmented reality and virtual reality solutions are going to be displaying on the screen. So that was everything from my side. I think I was on time. Thank you, everyone. If you have any questions, feel free to ask, and I will be glad to answer as I can.
Yes,
So
I think there is a question in the chat from Finian Joyce. I don't know if you see it.
No, I can see it. Okay.
It's can you demonstrate what the Mcx Augmented Expert might look like and what it might do?
That is one of the solutions that our partner Airbus is going to develop, and its main objective is to share the video. Perhaps our partners, if they are here, they can give a better overview. But the main objective is to be using mission critical communications to share information among multiple participants in those groups. And if a user is sharing a screen with the information that he or she is seeing, and the user is able to point, for example, an element on the screen, and any other expert in the group can be seeing that information and add any additional information on top of that information, on top of that shared screen. I don't know if I understood if I explained successfully your question.
Yes,
Okay.
I think we have time for another question. I don't know if you see the chat, Arbil. There's one from.
Yes, I see one question regarding, do you take advantage of simulations? And in this case, we don't have any specific scenario when we are going to build simulations. Perhaps I'm not really sure about that, but perhaps in the training part, in the solutions that will be creating the training applications of the AR and virtual reality applications, they will be using some simulations. Yes, you mentioned, for example, for fire and smoke propagation. Yes, and well, I think in this case we still need to discuss more in detail how we are going to simulate or to how to say to recreate the scenario, because well, the truth is that we are not going to provoke, as far as I know, any real fire smoke. So we will need to see how we are going to address these scenarios. I think this is still somehow an open question. Okay, there is another question. Are you concerned that with augmented reality the user will be distracted and can trip over object while walking? Yes, well, using augmented reality, depending on the device, this can be something that can happen. If you have any distraction or whatever, this can be true. But the thing is that augmented reality, it doesn't remove the real scenario, so you are able to see what you have in front of you. That's the main difference with the virtual reality. Okay. Anything else? Yes, well, any kind of distraction, it is possible to have any kind of distraction, but somehow, well, we need to think that augmented reality is not going to be the full solution to solve any problems. But also, if we can think that if the first responder needs to go using a map or something different, or any other kind of devices, that also can be distracting. Yes, also, there is another question. Do you have any results confirming that augmented reality can influence the safety? Well, in our case, we haven't done any real test or any real results to confirm or to discard anything. But this kind of things somehow will be surely assured or try to assess during the pilots to try to get the real feedback from the first responders to see how they are going to how they feel using the technology and if it's valid or what can be improved or what can be corrected. Yes. Yes, okay. What technology are you going to use for location of rescuers, victim stakeholders? Yes, in this case, we envision that having drones, for example, will be a good supporting solution. Also, for indoor localization, one of the partners, I2CAT, also is providing an ultra-wideband based solution to locate people inside buildings, for example. So we will be using different supporting technologies in this case. Okay. Well, there are many questions here also.
I think, Arbil, maybe you can continue to answer the question under the chat.
Okay.
Because now we can move to the next speaker, because I think it will be very interesting to get also the practitioner perspective on this. So I'm very pleased to give the floor also to Rafa Kopani-Peris from the Valencia Port Foundation. So Rafa, thank you to provide the practitioner perspective on the use of augmented reality.
No. Good morning. Hello. Thank you very much to you and all for the invitation, and thank you, Harry, for this for your presentation. I think that you have explained quite well what are the main capabilities of the augmented reality, which I'm going to comment in our port, at the Valencia port, in order to give you some vision about the use of this kind of technologies. So I'm going to share my presentation, just a couple of seconds. Now it's ongoing. Can you see the presentation?
It's coming up.
Okay. Yes, we are waiting. Okay.
If you can put it full screen, yes.
Yes, can you see it now? Yeah. Okay. It's because I can see, but maybe you. Okay. So, well, the idea of our presentation is giving a perspective from the Valencia port in order to use this kind of technology against emergencies and different events. So, firstly, I would like to give you what is our.
Sorry, Rafa, but we can see the notes, so it's not perfect in full screen. Yeah.
Okay.
On the.
I have two screens. Okay, just a moment, and then duplicate.
Or I can share the presentation for you if that's easier.
Yes, because I have two screens, and then now.
No, we still see the.
Because I have to disconnect, maybe. Maybe I have to disconnect. So now.
No, unfortunately, it's okay. I will take the ball and I will share, and you can just ask me to switch the slides.
Okay, but better because my screen, but bigger screen is better because with the computer is okay.
Okay.
Well, I have commented in previously. The idea is to give this vision about the use of different technologies. I have classified my presentation into parts. The first one is give our profile as Valencia Ports. Although Valencia Port Foundation is the research and development center of the Port Authority, we keep in touch with them in order to provide innovations in case of this kind of technologies. Augmented reality, the use of drones and other technologies. Please, the next. And also, we will provide you which are the main scenarios that we have defined in order to test the technology, the mentioned technology. Next, please. Well, this is the Valencia Port Foundation. As I mentioned it before, is the research and development center of the Valencia Port Authority. So we participate in many projects related to different fields, sustainability, in this case, security and others. So the idea is looking for new technologies, the use of this kind of methodologies and technologies in case of emergencies and to fight pollution in case of fires and so on. Next, please. And Valencia Port, as you can see here, we have mainly the two different protocols and procedures related to the ISPS code. Is if you don't know the ISP code, is the protection of ships and port facilities code. So that has been developed by the International Maritime Organization. So we have here different protocols in case of what happens when we have identify a fire at the port, a ship crash, so different events. So we have this kind of protocols with the coordination between the different responders, of course with the Valencia Port Police, but also in cooperation with regional authorities such as the Valencia Police, firefighters, and so on. So we specify in this code the different, the behavior or the action that we have to take on during the emergencies. And also we have a command and control center that we name here Coordination and Communication Center. It's a command and control center 24 a day, 365 days a year that receive information from the land side and also from the sea side of the port through or via different CCTV cameras, also fire alarms, smoke detectors, the barriers, gates, also the resources from the Valencia Port Police and so on. So we have different resources in order to detect, identify some emergencies, accidents, and so on. And this command and control center is one of the best resources that we have in order to know what's happened at the port, and in case of any accident or any emergency, we can respond very quickly. This next one, please. Apart from this command and control center, we have different technologies implemented at the port, more focused on the cargo flows in order the detection of explosive or radiation and so on. As you can see in this slide, we have implemented the container security initiative in order to control and check the different traffic of containers. We are talking that the Port of Valencia, we are talking about the more than 5 million TEUs a year. So we can expect, not all of course, so it's a minor percentage, but we have installation and facilities in order to check and scan some of the containers. Also, we have implemented other initiatives such as detection of radioactive products, the megaport. So when we send containers to USA, we have to check the containers in order to provide information. And next, please. So in this regard, apart from the the more investment in technology and in scanner devices. Also, we have other devices and other barriers, such as the perimeter control, fending, as CCTV cameras, I mentioned it. Also, the use of the traffic, the marine traffic, that is controlled by the pilots at the entrance of the port, with the ACE or radars and cameras in the mouth of the port. So we have, as you can see here, we have different technologies, but I have to say that the opportunity to participate in this project in Response is that we are knowing new technologies that we can use and can improve our capabilities against this kind of events, emergency events that we are mentioning during the presentation. The next, please. Well, experience in projects is very quickly. We participate. We have participated in many projects. We have coordinated others about physical and cyber threats. Also, with cooperation with first responders like firefighters and Valencia Police and other authorities. Also, we are involving here in projects like Praetorian. That is a project that started in June. That is how to coordinate different authorities against cyber physical threats and events. So we have a lot of experience in this kind of projects. So we are very interested in improve our methodologies, improve our technologies, and of course, in order to guarantee the safety and security of the port and the people who is working and visiting the port. And now we pass. I'm going to present what are the main, that maybe is the most important part for you, that which are the main pilots or scenarios that we have defined. The main goal of this scenario is how to test the different technology. So we have to define or create like a real scenario in order to have to take the opportunity to test these technologies, augmented reality, but other like the use of drones and any other technologies that we are defining and we are developing in the project. Please. So in this case, in this context, we have defined two main pilots. One of them has been focused on spills, on marine pollutions. So as you know, you have here the accident that occurs related close to the ports. Here is only a very short introduction about marine accidents with human errors or not, and also with the spills and the problems that we have in many coasts and close to the beach. Because at the end, ports, in our case in Valencia, for example, we have two parts at north and at the south that are touristic beaches. So the idea here is to control and coordinate any operation in order to avoid this kind of problems. So next, please. Yes, the information about some examples, but I'm going to end. Although I have commented that the 5 million TEUs that move Valencia port, in this case, Valencia is the 5th port in Europe when we talk about container traffic. The second in Mediterranean, and the first of Spain. So it's a big port, and we cooperate with different first responders also, like Port Police in this project, with the Valencia local police, with SACEMAR, that is the rescue team, and also is a company, an organization who has resources in order to fight against pollution. So we have involved this company in order to support us during the scenario of this first pilot. And a second pilot will be about a crash of two trucks. So we have defined both of them, oil spill and crash of two trucks, in order to test the different technologies developed and commented during the workshop. Next, please. some pictures, animation of, in order to, you can see here the picture of Valencia Port, the different area, the different basins of Valencia, and here we are going to define different locations in order to demonstrate the use of these technologies, please. Okay, then start with the oil spill. The oil spill would be at the north of the port. Well, we create here like a story about that we have strong winds, some problems with the engine of the vessels. So if you want to pass the presentation, because it's animation, so a container basically is approaching to the port of Valencia. So we create this kind of scenario in order to produce that an oil spill occurs near the coast. You can see here the pictures where you can see the oil pollution graphic and the consequences it has to the port, but also to the main part of the city, to the touristic beaches at the north of the port. And then the idea is to recreate, to define the different actions and coordination with the Valencia police, and also with the use of the different technologies. Next, please. So here is one of the, I think that where you can see all the scenario is what, for me, is the most important slide of this presentation, because of the others has been an introduction. You can see here the picture, but for example, different steps. Which occurs during the drill that we are going to take during the project. The captain alerts the command and control center that I have explained before, that has problems with engines, strong winds, and so on. So at the end, everybody is coordinated by the command and control center. The port police arrive to the location in order to know exactly which is the location, the impact, and so on, and send information to the command and control center, who activate the National Maritime Plan. The National Maritime Plan has different protocols, and it's via 112 call, and advice to the harbor master, the Valencia local police, and of course to the SACEMAR, that is the main company, in order to respond against this kind of oil spills or maritime pollution. So the idea during the drill is to organize and to an advanced command and control centers, where we are going to coordinate all the activities. So the use of the 4 and 5G networks is very important, because some problem of the use of technology, if it goes beyond the port, is complicated. The information from the different technologies, such as drones, robots, and other wearables that we will use during the scenario. So also, all these kind of technologies will be covered by 5G. So that is the idea, to improve the communication systems, the networks. And with the use of the drones, we can check the area, the polluted area, in order to receive information in real time that what is happening if we have different vessels clear, swimmers, bathers, and so on. So the idea is to control and to monitoring exactly what is happening during the situation of these drills. And also we will receive information from video about the meteorological data, what has happened, in order to know and to the making decisions to know exactly what will be the next steps. So the idea of this scenario will be then to test this kind of augmented reality in this context, that we will explain later on in a slide, in order to know exactly what is our capabilities with the use of this technology. Please, the next. The idea now is only to show you which are the different scenarios. So, and then once you know exactly what the scenarios are, I will give you which are our thoughts about the use of these technologies. here in the augmented reality for first responder, deploying the scenario. So it's very important to know the location, to know exactly or receive information about the location, a display location, and extent, and what is the impact of the spill. The next, please. You can see here, so the idea will be receive this kind of technology will be mounted on a drone on some vehicle in order to receive information of what's happened, and also we will complementary with the meteorological data in order to know exactly what is happened during the drill. Next, please. Okay. Here also we coordinate this drill, as I mentioned, with the Valencia local police that will be in the touristic beach. Here, checking what is happening, what is the impact of the spill is coming is closing to the sand, to the beach, and also the detection of some maybe swimmer or some people near the impacted area. So it's quite important to know exactly what are the different problems that can occur during this oil spill, and then we need all the technologies to receive the information in real time in order to respond quickly. The next, please. You can see here in the picture the oil spill you receive in your smartphones, the iPhone, Android, and so on, and you can receive exactly with different colors the oil spills, and if you can find any obstacle close to the area. Okay, the next is the same user location, so you know the impact, the user location, and then you can find here visible detection to the user. So the idea is receive this information that is very important in this case of situations. Next, please. Okay. Yeah. That has been the first pilot, the first scenario, and also we have defined another one that is more that occurs at the land part of the port. So it's a crash between two tracks, and the idea is very similar in order to receive information. So at the end, we need, as I think that Harvey said, it's very important because the use of this kind of technology can trace wide areas. So we can monitoring areas in the sea side, in the land side, and we can receive a global vision of the situation. So it's quite important to know exactly what are where are our resources, which is the impact, and so on. So the idea here in this second scenario, as you can read here, is the crash of two trucks with dangerous goods, so inflammable, also with toxic gases. So the idea is to know exactly what happened close to the city and to send and coordinate well with the different authorities. The next, please. And this is the other slide, as I mentioned before, where you can see a summary and a sum up of the different steps of the scenario. So occurs a crash between two trucks at the port. So with inflammable products causing, of course, a big fire. So and there is an information to the command and control center. So the port police arrive there in order to first to have a first evaluation of the situation, and then can inform in the field, can inform to the command and control center. So the procedure is the same, it's a call via 112 in order to coordinate with the different actors, with the different first responding authorities, as the local Valencia local police, the firefighter, and so on. So also we have include, no, please, the previous one, because it's a long slide.
Yeah, Rafa, sorry, but how many slides do you still have? Because We are getting short in time, and
okay, perfect. This is the last one because after is very quickly.
Okay, good. Thank you.
Okay, so because here the pattern, as you can see, is the different steps, how to coordinate the different responders. Also, the same as in the beginning, the previously, to create or build a command and control center, advanced control command center, in order to coordinate between the different authorities, and then the use of the visualization, augmented reality, with the use of mounted on drones and other technology. So the idea, this kind of technology send information to the Valencia Port Police, to the Valencia local police, and also to the firefighters to know exactly what is happening. So the next, please. And then the idea is use this technology. We are not technological developers, but we can test and provide a real scenario in order to know exactly what are the main barriers of these technologies. You can see here a picture that we can, for me, was one of the most important aspects of this technology is, as I said, that the technology sends information of the in real time of the situation. So can trace wide areas of the port and send this information that is very valuable information to the different first responders. The next, please. Here, you know, it's more focused on the technology, how to keep it with cameras and so on. The use of mobile command and control for the use of first responders in order to know exactly what's happened. So here is the different use that we see very valuable for us in order to be used in this kind of operations. The next. Well, here is a sum up, and the sum up that you can free visualization, but at the end is the main aspect are the use of wearables also in order to know where people are. They use with the smartphone, so you can receive the information in different devices. So it's quite useful for the different apps and so on. The next one, please. You can see the use of different applications that has this technology. So, and that's all for me on my side. I don't know if you have comments, question. I can write also answer in the chat.
Yeah, I think that we have no time for answering live questions now. We are running a bit late. So if there are questions, please answer them under the chat. Thank you, Rafa. So
Okay.
now we will move to our I don't know if we say sister or brother projects, also working on the technology for first responder. I'm very pleased to give the floor to Guillaume Inglese, who will present Ingenious project on the perspective of Ingenious on augmented reality.
Yes, good morning. Can you hear me?
Yes.
Oh, okay, great. I suppose you can see my screen also.
Perfect.
So I'm Guillaume Inglese from CS Group, and I'm going to present you the Ingenious perspective regarding the augmented reality work. I will shortly present what Ingenious is about, then move on to the end users' expectation about augmented reality in our project, and then show what we are trying to achieve and how. And finally, just give you some word about where we stand. So Ingenious, this project is funded by the European Union on the H2020 Research and Innovation Program, and it's also funded from the Korean government. And its topic, it's technology for first responder. And our goal is to build a first responder of the future. The consortium includes 23 partners from 13 countries all over Europe, but also from South Korea. The project will end in August 2022. In Ingenious, we will develop the next generation integrated toolkit, the NGIT, for collaborative response. And it has 3 pillars. The first one is the smart first responder. The second one is the smart devices in the air and on the ground. And the last one is set of services with multi-fusion expert reasoning, C3, and mobile applications. The smart first responders will have an helmet, uniform, wearables, boots, and canine units to assist them. The smart devices in the air and on the ground will include micro indoor drones for deployable positioning system, and also multi-purpose autonomous exploring drones for monitoring and detecting. And finally, the last pillar is about the common operational picture with a C2, sorry, that will be augmented with information from the multi-source information fusion that will be visualized on the C2, but also alerts coming from this fusion system to the AR device itself. The system will also include mobile application kits with, for instance, triage and patient tracking, social media analysis, and worksite operation. Regarding the validation and testing, we have an ambitious program with 27 laboratory integration tests, 18 small-scale tests on the field, and 2 large-scale field validation. We'll study several use cases and address different incidents like industrial incident, earthquake, fire, damaged building, loss of communication, and so on. Now, let's move on to what our end users expect about augmented reality. Safety comes first, as they said. The data presented must be transparent or do not hinder the field of view. You already had an introduction to what is augmented reality from Arwil, and thank you about that. So the end user will see the environment, but what we will add in front of it should not be obstructive. Do not block its field activities. Should not be intrusive. And finally, should be relevant to the person using it. Relevance depends on the situation. Is it a fire? Is it a terrorist attack? Do we have a gas leakage? And so on. But also the task at hand. Is it a search and rescue operation? Is it firefighters putting out fires? It depends. Also, we have to take into consideration the level of command. For field operator, the information that would be displayed should be minimal. For a team leader, it can be related to the team. And for the operator at the control center, you can display much more information to have an overview of the situation. What they expect also is capability to work indoor and outdoor. They also want to have a voice input to applications, real-time provision of alerts and messages. Also, they want to see the teammate position. And finally, have hand-free interaction with other components of the Ingenious project. For instance, the triage patient tracking to display the status of the victim just by looking at a specific QR code. Now, let's move on to how we will try to solve all this, to address all this expectation, and how using augmented reality. First, it's about compromises to get the best out of the latest augmented reality technology. what we are trying to produce should not be a gadget, because it's for operation. We have to keep it simple, not to increase the mental load. And this taking into consideration the technical limitation of augmented reality. Today, hardware is not designed yet for operational use in the outdoor or for wide area, with also weather conditions such as rain. It's also challenging to display geolocalized information for an uncontrolled environment. It's easy to display something on augmented reality into a room. It's another story outside on the field. If for Ingenious, our goal is to primarily address the field operators. And for that, we have selected two augmented reality devices. The first one is the Array 2, which is lightweight and enable plain augmented reality in a head-up display. Why we selected this one? Because it's easier to integrate into a helmet. And in Ingenious, we aim at providing the smart first responder with an helmet. The second device we selected, it's a HoloLens 2, which provide mixed reality capabilities with multiple sensors and natural interaction by hands. Because we want also to explore future capabilities or advanced capabilities that this technology can propose. So what the augmented reality can solve? First responder tasks require full attention and usage of both hands. This heavily limits the type of device they can bring and use. And here, augmented reality can enable a true hand-free operations. First from voice command, but we have to pay attention to limit the number of commands and also differentiate them. And sometimes the environment can be noisy, which is a limitation. Then the hand-free operation can be done also with mixed reality interaction with on-demand user interface that will display buttons or visual components. The augmented reality can also directly grasp the user attention, even in complex situations, without any action from the first responder. The visual notification is displayed in front of him or at certain location in his field of view. And this information can automatically fade out so that he is aware of this, but doesn't have to do anything more than its task at hand. Finally, the lack of information can result in man-made error and disorganized emergency response. And here, the augmented reality is the next step in providing situational awareness to the field units. By providing real-time provision of visual notification, but also annotation into the environment, showing, for instance, useful equipment, such as switch or valve, but also risks or hazardous substances. This coming from the control center or other components from the project. But what is interesting is that the augmented reality with the goggles provide the first responder with the ability to precisely report geolocalized information from an incident or from someone that is injured. That is an added value. And these are the things we will explore during the project. So up to now, what we were able to do due to the COVID-19 pandemic, it's to present the augmented reality and mixed reality capabilities remotely to the end users. But luckily, some of our end users already experience augmented reality, so they were able to provide useful feedbacks to the proposal we made for augmented reality features. We have work ongoing to create and tailor the augmented reality features to the engineer's use case, and we will have our first on-site demonstration planned after the summer. And that's it on my side. Thank you for your attention, and I'm free to answer any question you may have.
Thank you, Guillaume. I do not see on the chat any question addressed directly to you, but please check the chat if there are some more later. I think that now we can move to our other speaker from the FASTER project, Kostis Konstantoudakis from CERT. Kostis, the floor is yours.
Thank you so much. So you can hear me and you can also see my screen?
Yes.
Great. So first I'll say a couple of words about the FASTER project. So the consortium is composed from 23 partners, including industry, SMEs, a lot of research and academic partners, and also a lot of first responder organization partners. We comprise of 10 EU countries plus Japan. We are planning and actually have already done the first iteration of 3 major international pilots. And because, of course, due to the COVID pandemic, travel is difficult or impossible, we have also organized a lot of impromptu additional local pilots so that partners from the same country can meet locally and test their technologies. So FASTER has a lot of technologies for first responders. We have communication tools, 5G utilization. We have gesture-based interfaces, security, communications, of course, augmented reality, which I will go over in more detail in the next slides. Canine, like police dogs applications, and drone applications, and a lot of stuff, wearables, and also a common operational picture that is like an overview for the team leader that collects everything and displays it on a map, and also providing additional media like videos or images where they are available. So FASTER is just finishing its second year this month. In the beginning, of course, we spent some time on getting our requirements from end user partners and also from external end users, getting the specifications for our tools and architecture. We have completed the research and development of the tools for the first version. We have completed the first local pilot in Greece just before the second wave of the pandemic hit. We have completed the first iteration of 3 main pilots in Spain, in Italy, and in Finland, where a lot of tools were deployed remotely, but the pilots were a success. And here we are now. Now using all the feedback and the experience from these pilots, we will spend the next months in refining the tools and getting better results out of them and more appropriate for use. And we're planning, as I said, a lot of local pilots in Portugal, in Finland, in Poland, in Japan, in France, and of course, the second iteration of our 3 main pilots that aim to validate and demonstrate all of the faster tools. So, regarding augmented reality, we have 3 main aims regarding augmented reality. One is to have on-the-field information that is in context with the user's surroundings, that is also intuitive to see and understand and does not disrupt and does not detract from the focus of the user, who is a first responder, of course. The second is situational awareness. So we aim to enhance the perception of the user by showing them things that they could not see by themselves. And optionally, this can also be in context with the surroundings, depending on the use case. And the final aim is to have a human-machine interface. Of course, augmented reality mostly focuses on visualization, but having an appropriate interface for augmented reality, like gesture control, for example, excuse me, is also a part of many augmented reality systems, like the HoloLens, which we are mostly focusing on. And so, on the first point, I will shortly give the floor to Guillaume from CS, who is doing some really exciting work on giving real-time geolocalized information to first responders, depending on where they are and what risks or objectives they have. On the second part of situational awareness, I will present vision extended by drone use, UAV use. And on the final part, I will also present our work on gesture control for drones. So please, I would like to give the floor to Guillaume for the next couple of minutes.
Yeah, Jean, can you please
Yes, yes, I
unmute?
just sent
Thank you so much. So hello again. I'm back for a few slides to give you some information about the work we are doing also in FASTER. So the goal here for the real-time shared and geolocalized information is to provide up-to-date and geolocalized information from the control center to the device directly, such as first responder and team member position on a map, identified victim, or useful in equipment they may find on their way. But before developing this prototype, we start in collaboration with NZOSP a study to define intuitive and non-descriptive interaction for augmented reality. So on this study, we identified a required and possible interaction for the first responder with the voice, with fingers, physical button, or even a virtual tablet, let's say. We define also where to display the information on the side of his field of view or on the lower level of his field of view, so that he can just tilt his head and see the augmented the holograms, so augmented information. And also we define how long this information should be displayed. Finally, we test how to represent the information as icon with colors, what type of icons to use according to the information to be displayed, if it's related to water, if it's related to a risk or to a victim. And this to be displayed on a map and various type of maps. Okay, thank you. On this presentation, we display an initial result. Yes, you can play, showing how the map looks like. So the map is displayed on demand from a voice command. And here, the first responder can see its location, the location of victim, and the hazard area also. So thank you for replaying the video. It was a bit fast. Okay. So the idea here is to improve the situational awareness and help the first responder navigate through the building. In its current version, we just display this information as point, but on the next version, we are planning to include also a path to a point of interest coming from a specific component from Faster. Next slide. Okay. What has been on also on the augmented reality work in Faster is a lot of field tests from NZOSP using the HoloLens 2. The idea was to check how the HoloLens 2 behave in operational condition, let's say, and what the user can see in various environments and with various conditions, such as smoke, outside environment, or using personal protective equipment. So they test the augmented reality visualization to check the visibility and quality of 3D objects. They also display a color scales to check what would be the best color to use for the icons, for instance. And they also try to look in different direction. We having also the sun in direct line of sight. They test also the augmented reality manipulation. They try to click on buttons, virtual buttons, with different size to check what would be the perfect size for their operation. They try also to interact with the 3D objects. And finally, they test the voice command with the different equipment using simple command and also in various noisy environments. All these tests provides very useful results for the production of the prototypes. And that's it for my presentation. Thank you, Kostis.
Thank you so much, Guillaume. So the second, our second application is the UAV extended vision. So this aims to improve situational awareness for the first responder, and also in a way to help them focus and minimize distractions. And finally, to allow a more versatile use of drones during response missions. So the way we go about it is we want to present the UAV's camera feed in augmented reality, of course in real time, and optionally in context. Secondly, to also track the drone in augmented reality so that we know in augmented reality terms where it is in relation to the user, even when the drone is out of direct line of sight of the user or it is too distant for the user to see clearly. So when we're talking about a contextualized video feed, means that the video feed is registered with the environment and it is presented to the user in the approximately the correct position and transformed so that it matches with the user's own point of view. So the use case for this technology is that the drone can go and look at some place the user can't go or can't see. for example, behind the wall or behind the car or on the second floor of the building or something like that. And then the video is transformed from the drone's point of view to the user's point of view. And ideally, the user would gain a sort of X-ray-like vision in augmented reality. So you can see, for example, from this concept image on the right, that so in this image, the user is standing, and you're seeing the image from the user's point of view. The drone is on the, this is a chimney surrounded by some plants that you can see. So this is a chimney. The drone is on the far side of the chimney. You can see here a sort of virtual drone that says approximately where the drone is on the far side of the chimney. I will go over this on the next slide. And the video feed from the drone that is displayed in a way that actually lets the user kind of see through the chimney to the street and the buildings beyond. Of course, you might note that it is impossible to affect a perfect transformation. So, for example, this building on the far right is also this building here, of course, because we're focusing on showing the nearer parts in perspective, like this wall here. But the point should be that it gives the first responder an idea of what is on the far side of the wall. So, of course, we have some requirements for that. First of all, we need to know where the drone is so that we know where it looks at and position the video feed accordingly. And we also need to have low latency streaming. And in an ideal case, we would also benefit from depth estimation so that we know how far away the objects of interest are from the drone and position the video feed accordingly in augmented reality. So the second part of extended vision is, like I said, to know where the drone is in augmented reality. In order to find that, we can use GPS, which of course only works outdoors. And we can use the inertial measurement units from that are on board the drone, which of course can be used both indoors and outdoors. But there is some error in those, and it tends to accumulate over time and needs correction. The orientation, of course, is fairly easy to get. We need just to read the onboard drone compass, which gives us the heading. And before it works, we need to do some calibration so that the real-world location and heading of the drone are corresponded to the augmented reality, like the virtual world location and heading. I have a very short video showing this. So this is the real drone, and you can see the virtual drone in augmented reality. You might know that they don't correspond precisely, but the virtual drone will follow the real drone and let the user know where it is, even behind walls. Future steps towards that would include some error compensation and some measures to improve the latency. You can see that the virtual drone is maybe 1 second behind the actual drone. So this is tracking. The second, the final actually part of augmented reality applications is gesture control for the drone. Now, our main aims for that is to provide more intuitive control, to make it easier for users to learn how to control drones. Everybody who has ever tried to control a drone, you know that you need both hands, and you need like 2 sticks, and one stick controls pitch and roll, and the other controls yaw and throttle. So it needs some coordination between the 2 hands. It can be difficult for beginners to get used to. We aim to have a single-handed control so that a person can control the full range of drone motions with one hand only, which is both easier and more intuitive, and it also leaves the other hand free, maybe for carrying equipment or doing other stuff if necessary. So for that, we've been using hand tracking from HoloLens 2, which uses some depth sensors to track the user's hand, also for its own interface. The various hand states correspond to some commands. We have 10 commands, which is like throttle, up or down, yaw left and right, pitch forward or back, roll left and right, and also commands for takeoff and landing. We have implemented 2 different modes. One is finger-based. That is, the main focus is on which fingers are extended, like that. And the other mode is palm-based. So you imagine that the drone actually is your hand, your palm, and if you want the drone like to go left, you tilt your hand to the left, or you want the drone to go up, you move your hand up. So this has proved to be more intuitive. We have tested it with some first responders who are also experienced drone pilots, and they said it is probably the better option. I have also a short video about that. It still doesn't work perfectly. It needs some robustness improvements, but we are confident that it should work pretty well in the coming months. So roll to the right and roll to the left. I'm sorry that when I was wearing the HoloLens, I didn't realize exactly what the field of view of the camera is. So sometimes the drone is out of sight, but now you can see it yaw and now land. So this is my final slide. So the future steps for all of these would be to integrate all 3 subsystems in one. That is tracking the drone, presenting the video, and also controlling it with gestures. We need to address some performance issues. Hand tracking is a pretty computationally heavy process. And of course, video rendering also is another demanding process. Of course, like I mentioned, we could improve robustness. We could improve tracking latency. We could also compensate for the drone tracking errors. This could be, we're thinking of using a visual recognition system that would also track visually the drone when it is inside and correct its position, or perhaps use both GPS and time use so that one can correct the errors of the other. We could also automate the calibration process, again, using GPS or visual recognition, because sometimes this takes a few minutes, which might be crucial in disaster response. Like I mentioned before, we could utilize depth estimation to improve the placement of the video feed. And of course, we could also expand and put more options inside the user interface. So for example, the user could toggle between contextualized video feed, that is like X-ray vision, or a drone point of view video feed that might be more useful in some cases to just have the video from the drone's natural point of view. So this is all from my side. Thank you so much. And I will be happy to take any questions if we have time.
Yes, that will be challenging. Thank you, Kostis. You have one question on the chat, so maybe you can answer it. It's about Uiv Gesture Control.
Yes.
So if you can answer, Drazen, yeah.
Yes, it can be done with the right or left hand. We have already tried it both ways. It's a fairly simple thing. It can be something that the user selects when they first start up the application.
Thank you, Kostis. So I think that we are running out of time. I would like to thank all our participants and presenters. I think that we see very interesting technology developments. The upcoming challenges will be, of course, the performance issue and the usability issue for first responder. So just for the participants, you will receive all the presentations and the recording of the event. And please stay connected to Respond A website where you will find also additional information. So I really want to thank you all, and also our two partner projects, Faster and Ingenious. So thank you all for this very interesting session today. Thank you. Bye-bye.
Thank you, Maria Cristina. Bye.